Hello and welcome. In this video, I will show you how to use RStudio to perform descriptive analytics. I will be assuming that you already know the basics of R and RStudio, and you also know how to use RStudio Online. I will be using RStudio Online on POSIT Cloud, but you can perform the descriptive analytics if you have RStudio locally installed on your computer. I will assume that you are already familiar with the basics. If you are not familiar with R and RStudio basics, I will strongly encourage you to first watch another video I have made. The link to that video is given in the description box. So I have already written the code here. I will be executing this code and I will be explaining how to interpret, and then finally I will show you how to use our notebooks to share your analysis. Okay, so first of all we need to load data into load data. I have already uploaded that data file to online environment. It is here, suppliers data .csv. I will first be reading that data set. So this is the code: supplier data read.csv, supplier underscore data.csv, and we will be saving this in supplier underscore data. I run this line of code, and as you can see, the supplier underscore data has been uploaded. Next, we will be using certain packages. You need to understand what a package or a library is. There are some functions already available in base R. When you install R, those functions are already there. But some advanced functions related to some particular type of analysis are developed by developers and are made available through packages. Those functions are not available in base R. So those set of functions which are developed by someone and are packaged into a package or library can be installed in your R environment and can be used. The packages we will be using are ggplot2, which is a package which is used to create visualizations. Similarly, we will be using another package, reshape2. If you have never worked with these packages previously, you will first need to install these packages. The function for installing these packages is install.packages, and then you have to write the name of the package you are using. But since I have already installed these packages, I will not be running these two lines of code. However, even when you have installed a package, when you want to use it, you have to call it or load it. For loading an installed package, you use the function library or require. Okay, so we are going to use this function library ggplot2, and when I run this code, you can see that library ggplot2 is loaded into our environment and now is available. Similarly, we are also going to use library reshape. Okay, now before we move on to performing analysis, let's first have a look at our data. So this is the supplier data. I can simply click it here and I can see what type of data it is. Alternatively, I can also use commands like structure, str, and dim to see the shape and the structure of the database. I can also use head functions to see a top few rows to get an understanding of what type of data is there. All of these things are already covered in the video that I previously mentioned, and the link to that video is given in the description box, and you can watch that video. We have in this data, as you can see, supplier ID, which is a unique ID for every supplier. We have category of suppliers. For example, there are different categories: printing, inks, adhesive and chemicals, printing and inks, other packaging components. Then we have the city of the supplier: Abbottabad, Karachi, Jung. These are different cities of Pakistan. I must explain that this is not the data of any real company. This is a synthetic data set which I have created for the purpose of demonstration. But the actual data, if any company has a data set like this, will also look same. Okay, then we have consistency, which is a categorical variable. Some suppliers have high consistency, some have low consistency. And then rejection incidents, if how many rejection incidents have happened for each supplier. Then we have compliance with specification. This is again a categorical variable. Compliance with specification is either high, moderate, or low. And then we have average response time, issue resolution rate. Then we have for each supplier length of partnership, and past performance trend, declining, improving, stable, etc. Order fulfillment rate. Then lead time compliance, scalability potential, which again is a categorical variable. Price fluctuations, again stable or variable. Competitive pricing, this column shows whether this supplier's prices are competitive at market, or above market, or below market. And then we have the distance of supplier from our location, the transportation, reliability of the transportation method of the supplier, payment term flexibility, again moderate, high, low, etc. Credit terms are limited, or available, or not available. And then we have a column label, whether this supplier is at risk, or whether this supplier is reliable overall. We are currently not discussing where this data has come from. I mean, this is a very clean data set. Real data sets in the real world are not this clean. And as you can also see, this data is already aggregated. Data sets, when they are acquired, are sometimes not aggregated, and you will have to aggregate those. But all of these things will be discussed in some other video, and when that video is made, I will provide the link to that video as well. Okay. For now, I just want to demonstrate, if you have a data set, how you can perform descriptive analytics. Okay. Now, let's do some analysis. And first of all, we are going to perform some univariate analysis. Univariate analysis is an analysis which is performed on a single variable or a single column. So, first of all, what we can do is that if we have a quantitative variable, we can calculate its summary statistics. So, I am going to run this line of code here, which is supplier data delivery delays summary. So, what this line of code is doing is that it is accessing the delivery delays column in our data set and calculating its summary statistics. So, this code will give you summary statistics. So, let's run it. By the way, I have also explained in the video that I previously referred to how you can write these codes with the help of ChatGPT. I have made another video, in fact, specifically on using ChatGPT for writing R codes. I will provide the link to that video as well. So in this video, I am not going to explain code in detail. You can watch those videos and you can see how you can get help from ChatGPT to write these codes. By the way, these are not very complex codes, and you can understand these and you can write on your own. But now with generative AI, these codes can be written very easily. So I encourage you to watch those videos, and the links to which have been provided in the description box, to see how these are written. So now let's run this code. I have pressed this button here, run, and now I have got the output, which is the minimum delivery delays are 0. So there are some suppliers which have 0 incidents of delivery delays. First quartile is 1. First quartile mean that below 25% of our suppliers have delivery delays below this value. So the first quartile is 1, meaning that 25% of our suppliers have less than 1 delivery delay incidents, meaning 25% of the suppliers don't have any delivery delay issues. And then we have the median value. Median means 50% of the suppliers in our data set have less than 3 incidents of delayed deliveries, which is also good. And then there is mean third quartile. As by now you must have got an idea that 75% of our suppliers have a delivery incidents of less than 6. So looking at these statistics, it seems good. So most of our suppliers do not have too many delivery incident issues. Now these are the statistics, but we can also visualize quantitative data through various charts and graphs, and one such visualization is a histogram. So next what we are going to do is that we are going to create a histogram for average response time. So let's run this piece of code. These, as I have explained in previous videos, when you write something after the hash sign, it means that this is the comment, this is not the code, it will not be executed, but this piece of this is the piece of the code and it will be executed. So what we are going to do here is that we are going to access average response time column within our data set, and we are going to create a histogram. We are going to give it blue color, and then we are also going to add a heading, histogram of average response time, and on x-axis we are going to label it as response time. So let's run this piece of code and see what happens. So when we executed this line of code, we have got this histogram on the lower right panel. We can also zoom this and see it. So here you can also see that this is the response time. This is probably in hours. Okay, so you can see that most of the for most of the suppliers, the response time is on the lower side where the bars are higher, but some suppliers have a response time up to 50 hours, which can be a cause of concern, but we cannot conclude anything only on the basis of this histogram. Those suppliers, the nature of those suppliers and the nature of their deliveries might, if we consider that, it might not be that bad after all. So that is another thing. You cannot get the full picture by performing a single piece of analysis or single statistic or single chart or graph. You have to combine multiple things to get the full picture. Okay, so this is the histogram, and if you don't like this color, you can change this color as well. and you can also add, you can change the font and color of this title, and you can choose whether to show this here or not. And you can, if you want to make any changes, you can simply give this piece of code to ChatGPT and ask it to make changes the way you want. Okay. Next, we are going to create another sort of visualization, which is the box plot for order fulfillment rate. Okay, so we are going to again access order fulfillment rate column in our data and then create a box plot for it, and we are going to give it orange color. Okay, so now let's execute this line of code, run, and now we have got this box plot here. A box plot is a very useful visualization. You can see that this line shows the median. So you can see that the median value is above 90 and below 95 it is around maybe 92, 93. So this is really good. It means that 50% of our suppliers at least have a response order fulfillment rate of greater than 90 to 93%, which is really good. And this is the first quartile, this is the third quartile. So you can see even the first quartile is somewhere around 88. So we can say that 75% of our suppliers from first quartile up all the way up to 100%, that is 75% of the total suppliers, have an order fulfillment rate of greater than 88, which is really good for us. But what this shows here is that there are some suppliers who have low order fulfillment rates ranging from maybe 70 to somewhere around 76, 7, 8. This is very low order fulfillment rate, and there seem to be some supplier in this region. We should identify these and look into why these suppliers have such low order fulfillment rates. So that's how the descriptive analytics start giving you idea where to look. Descriptive analytics might not always give you the full picture, but they give you a good idea where to look. Okay, so let's close this and move to our next visualization. This visualization is for bar chart of supplier categories. And okay, there are two lines of code in this because okay, you can see that no visualization has been shown here. That is probably because there was not enough space. Okay, maybe let's try to zoom it out, but you can see that it is not there. Okay, so let's make this window bigger and try again. So sometimes the chart area is the chart is your chart is bigger and it requires greater or bigger space. So let's make this even bigger by dragging this leftwards and try again. So now let's try again. Okay, now you can see because now it has enough space and it has showed the bar chart. Let's zoom it out, zoom it in, and now you can see that the most of the our suppliers are for raw material suppliers, and then this category machinery and equipment, there are about 80 suppliers in this category, and then printing and ink category. So now you can see that the raw material suppliers are highest in number. So this is a bar chart which shows you the frequency of different categories. So you can also arrange it from highest to lowest, and if you want to do that, you can uh, ask ChatGPT to rearrange your code accordingly. By the way, I will provide the links to this data and this code, from where by following those links you can download these and practice on your own. Okay, moving on, let's create another visualization which is a pie chart, and we will these are the categories of suppliers. First we have created a bar chart for these, but we can also show this in the form of a pie chart. Okay, so now let's create that, and this again will have several lines of code, and now you can see that this is our pie chart. Okay, there are no labels here, only a legend which tells us that this red category represents adhesive and chemicals category, and then this is the biggest category. Let's see, it is raw materials. If you want, you can add labels here and percentages or absolute values instead of adding this legend. So if you want to experiment with it, download the code that I have provided, ask ChatGPT to change it so that it creates a visualization you want. I will strongly encourage you to do that. Copy this piece of code, give it to ChatGPT and ask it that I want labels instead of this legend, and then you might have to go over a few iterations. You will ask ChatGPT again and again to create the visualization you want. You will try different codes, and when you are satisfied that this is the visualization you want, you can you can finalize that. Okay, now let's perform some bivariate analysis. Bivariate analysis is in which you take two variables. So as I said, we were previously performing univariate analysis, in which we were analyzing only one variable or one column at a time. But now we are going to perform some bivariate analysis. So the bivariate analysis will take two variables. So we are again going to create box plot, but this time we are going lead time compliance and compliance with specification. Now lead time compliance is a numerical variable, and compliance with specification is a categorical variable. So what we will do is that we will create side by side box plots for different categories. Let's run this and see what it looks like. Okay, so it is taking some time to execute. Okay, again, no. Okay, oh sorry, yeah, this is it. Okay, maybe my internet is a bit slow right now, so this is why it is taking some time. Okay, so lead time by compliance level. So these are the supplier whose overall compliance is moderate, compliance with specification is low. There are some suppliers whose compliance with overall specifications is low, and there are some suppliers whose overall compliance with specifications is high, and these are the lead time compliances. I mean, this is overall compliance with specification, and this is the compliance with lead time. Okay, as you can see that the median values for low and high category are somewhat similar. In fact, no, these two are similar. This is slightly on the lower side, but you can see that in the moderate category, the suppliers who meet the specifications really well, but their lead time compliance seems to be problematic, because there seem to be a lot of suppliers there whose compliance with lead time is quite low, below this 70. So here you can see, instead of looking at lead time compliance only, of all the suppliers, you see in which category there is the most problem. So you can see that in this category there are some suppliers whose lead time compliance is quite low, but interestingly, the whose of the 75% suppliers have a lead time compliance of greater than maybe 85%. So this is the category where most of the suppliers have good lead time compliance, but those who have lower lead time compliance, their compliance is very low. There are many in that region. So this further helps you narrow down the space where to look for. Okay. Now we can also create a bivariate analysis or a bivariate chart, where we plot a categorical variable against another categorical variable. For example, let's create this and then I'll explain what it does. Okay. So this is a mosaic plot. Let's zoom it in and see what it is. So this is the price fluctuation. This is a categorical variable. Some have variable prices and some have stable prices. And this is the scalability potential, low, high, medium. Okay. So you can see that the suppliers who have low scalability potential, which means that they cannot scale easily, have stable prices. Okay, most of them. Actually, in most of our supplier, in all categories of scalability, have a relatively stable prices. But the medium potential suppliers, the suppliers who have medium scalability, have the most stable prices. Okay, and the suppliers in low and high scalability categories have slightly less stable prices, because their prices are more variable as compared to medium potential suppliers. So this is quite an interesting analysis, that the suppliers who have the highest scalability potential have the most variable prices of all three categories, because you can see that their variable section is comparatively bigger. So maybe this is we should we should approach these suppliers and ask them, okay, we appreciate your high scalability potential, but they are probably using it to frequently change their prices, because as they are scaling, their prices are also changing. So maybe we should be wary of that, and we should look out for that. Okay. Next, we can also perform multivariate analysis. The multivariate analysis, in which more than two variables are analyzed together. So let's create a visualization in which three variables have been plotted against each other. So this is a facet grid, and I will explain it after creating it. You can also create this with the help of ChatGPT. This code is quite long. So let's run this. Okay, it will be created. We'll have to wait. Okay, so this is the visualization. You see, there are three things here. These are the medium potential of scalability. These are the scalability categories, scalability potential categories. Some supplier have low scalability potential, some have high, some have medium. And then for each category, we have delivery delays in, these are not actually days, because we should, change this. These are the instances of delivery delays from 0 to 15. Okay, and then these different colors suggest, tell us that these are which supplier, I mean in this category, and in this, in the medium scalability potential from 0 to maybe 1, this is the composition of various categories of suppliers. So this seems really good, but the processing and understanding these multivariate charts becomes a bit difficult, because you have to think a lot. The whole idea of visualization is that it should make the understanding easier. It is still very easy instead of, compared to looking at raw numbers, but this, as you can see, is slightly more complex to process as compared to univariate and bivariate charts and numbers. Now you can see, let's take one category. In the high scalability potential category of suppliers, most of the suppliers have delivery delays on the lower side. Okay, so that is good. But some suppliers have high delivery delay incidents. But in low potential categories, you can see that there are very few in the highest region. So this is interesting. Okay, if you see in the medium category, there are many who have delivery delay issues on the higher side. Now let's look at this. So there are some suppliers who are who have delivery delays issues. They have medium potential of scalability. Now let's look at their composition. So most of them, you can see that the biggest is in this category is this machinery and equipment, and this is raw material. Raw material is the biggest category, so you can expect that it will be the biggest category in most of the things. But this is interesting, because machinery and equipment suppliers who have medium scalability potential, they seem to be having delivery delay issues. Now interestingly, if you look at this, in the low category and in the high category, the raw material suppliers are not there in the highest delivery delay issues category. Okay, so this is interesting, that this medium category, from all the visualizations we have seen, this medium scalability suppliers seem to have issues with delivery delay and order fulfillment, all those kind of things. So by looking at it from various angles, now we can say with relatively greater confidence that maybe let's look at these suppliers who are in the medium scalability category and come up with some strategies to help them overcome these issues, or maybe let's try to get more suppliers who are in this category. So that's how the descriptive analysis help you find out. It does not tell you precisely what the problem is, because the what part is covered in maybe or why some problem is occurring. That can involve some qualitative analysis, or that can also be done with diagnostic analytics. But the power of descriptive analytics is that it helps you narrow down your search. It indicates where the problems and strengths might be, so that instead of looking at everything, you should start looking in those areas. Okay, and then it also tells you whether you have issues overall or not. For example, as we saw previously, we saw that order fulfillment rates, all those things, they are in satisfactory, they have satisfactory levels. But that satisfactory level can again depend on the criticality of those things. For example, in some industries, 90% order fulfillment rate might be okay, but in some where the prices are high, or where the speed is of importance, a failure in order fulfillment, a 10% failure in order fulfillment might not be tolerable. Okay, so that's what the descriptive analytics is for. Now, as you can see that we performed these analytics, and when we created the next chart, the previous one was the previous one vanished, and we can copy all these charts and statistics and maybe paste those in a Word file and then share it with someone, or maybe make a presentation. But there is a better way, that is through R notebook. So to create, in which you can write your code, its output will also be shown there, and then you can save it as an HTML or a PDF document and share with anyone you want. So to create an R notebook, you will go to this button here, the plus sign, and choose R notebook. Okay. Now a R notebook is being created. You will see something here. You will not disturb this part, and the rest of things you can just remove. Okay. Here you will write the name of this notebook. Let's call this descriptive analytics for suppliers data, whatever you want to name it. Then you can insert your pieces of code. Okay, you can insert R code snippet here, and you can write whatever code you want to write. Okay, and you can also write plain text here, and using R markdown. What R markdown is, that you can adjust the font and boldness and italicization with certain symbols. So I will provide the link to the R markdown tutorial as well. That can take some time to grasp. You can see that as well. But for now, I have already created a notebook, and I will show you what is there in it. So I have named its title as Supplier Descriptive Analytics. Then I have, using R markdown, this double hash symbol means that this is a second level heading. Then I have added a code snippet which is reading the data file. Okay, I can just run it here. Okay, it has been run, and then I have added another heading called libraries, and then I have added the code for calling those libraries. Okay, and then I have added another heading, get summary statistics for delivery delays, and then I have added the code using this button here, summary supplier data delivery delays. This is the same analysis that we performed. Okay, now let's run this, and now you can see its output is being shown here. Then I added some explanation here. The maximum late deliveries from a supplier are 14, median is 4.195, but blah blah, whatever you want to write. So you can add your interpretations here as well. Then I have added the code for creating the box plot. You can run this using this button, and its output is also now being shown here. And then I have added some interpretation for this as well. Now you can prepare your notebook like this, and after you have finalized your notebook, you can go to this button here, knit, and you can choose to knit it as a Word document, a PDF, or an HTML file. So for now I am going to knit it to PDF. If you are using RStudio Online on POSIT Cloud, you will first need to enable pop-ups for this site. Whatever browser you are using, I am using Chrome. So in Chrome you can go to settings and allow pop-ups for this particular site. If you are using some other browser, you can go to its setting and allow pop-up blockers. If you are using RStudio on your local computer, you don't need to worry about it. So what I am going to do is that I am going to press this knit to PDF. Now let's run this. It is processing output file, and it has given me this file. Now you can see it is supplier descriptive analytics. That was my heading. Load data, its code, call libraries, its code, get summary statistics for delivery delays, its code, and output with the explanation I added, and then the next piece of code, its output, and the interpretation I added for it. I have included just 3-4 pieces of code, its outputs and interpretation, just to show you. Now this is a PDF document which can be easily shared with anyone. So they don't need to have RStudio installed. They can just read the PDF document, and this can serve as a presentation or a report of your analysis. So that's it for this video. Please subscribe to the channel and for more videos like this. Thank you.